Good morning, good afternoon, or good evening, and welcome to the why, the what, and the how of the software-defined data center. Great, so thank you very much everyone for joining us here today. My name is Michael Osterman. I'm the Principal Analyst with Osterman Research. We're an independent industry analysis firm, and we did the research for the white paper that you'll be able to download very shortly. Richie, Wade, and Peter, why don't you go ahead and provide a short introduction of yourselves, and then we'll get going.
Oh, for sure. Hello, I'm Richie Jennings. I'm an independent industry analyst, and I also do some other things. I'm old enough to have known Michael before there was an Osterman Research, so there you are.
Hey, great. Hi, this is Wade Holmes. I'm a Senior Technical Product Manager with VMware's Networking and Security Business Unit, and I lead our security architecture and solutions within the Network Security Technical Product Management team at VMware.
Okay, and I'm Peter Berry. I'm an Enterprise Technology Specialist over at McAfee. I focus on security within software-defined data center and cloud, with a very heavy emphasis on securing infrastructure as a service.
Excellent, gentlemen. Thank you very much. Just a little bit about the interface. It's a very simple interface. You'll see the chat box over on the left. Please ask your questions through that chat interface. We will not have an open mic for the question and answer session at the end, but we would like to entertain as many of your questions as we can. So please feel free to ask them throughout the webinar, and we will address them toward the end. So a little bit about the survey that was conducted for this program. We did 156 surveys in April, and really we wanted to focus on both the North American and the UK market. So we did most of the surveys in North America, but quite a substantial number in the UK, really to understand how organizations were thinking about software-defined data centers, what their plans were with regard to them, and so forth. And our focus really was on larger organizations. Organizations had to have at least 1,000 employees to be able to qualify for participation in the survey. And they also had to be operating either a private cloud or some sort of a hybrid cloud architecture. So we wanted to talk to people who were already in the business, if you will, of SDDC and moving forward toward a full software-defined data center architecture. We spoke to a wide range of industries, but the top 3 industries that we surveyed were financial services and insurance, healthcare, and manufacturing. So Richie, I'm going to let you take it over from here and really just sort of explain what a software-defined data center really is.
Sure thing. Thank you, Michael. So you'll see this abbreviation SDDC, which of course stands for Software-Defined Data Center. So what is that thing? I like to call it an umbrella philosophy for structuring data centers. And it has several business benefits, which we'll go into in a few moments' time. I think the key point that one of the key points that I want to put across is that we now see this thing as mature, by which I mean there are a range of vendors. There's a pretty vibrant market now. Vendors offering solutions that fit one description or another of the software-defined data center. It's not a wholly new, completely fresh piece of paper idea. It builds very heavily on proven technology, principally virtualization, that I'm sure most of you are familiar with. I hope most of you are familiar with, because we're not going to have a lot of time to describe what virtualization is. But it also adds other software-defined techniques, notably software-defined networking and software-defined storage, which we'll go into in some level of detail. There really isn't a lot of time in this short webinar to go into huge amounts of detail, so I'm going to give my first, probably of many, pitches to download the white paper that all this is based on. But in summary, software-defined data center is a way to build better data centers, more modern data centers. Now, at this point, I have to give a trigger warning. There will be some terrible, badly used memes ahead. So this software-defined data center thing, it abstracts and automates. There's a phrase that you hear a lot when people talk about software-defined anything. It abstracts and it automates compute, obviously, virtualized compute, something we're all very familiar with, but also storage and networking. A simple way to think about software-defined data center is it's a combination of virtualized compute, software-defined storage, software-defined networking, and also it often adds an overarching security piece. And as we'll see later, that security is an important benefit, an important aspect of the software-defined data center. So this idea of abstraction and automation, it brings tangible benefits, including into security.
Excellent, Richie. Thank you very much.
What's up, Michael?
So one of the things we found in the survey is that today the vast majority of data centers are already running virtualized. We found that about 70% of data centers today have virtualization running within them. That's going to increase to about 80% over the next couple of years. So certainly this is a concept that is well established. People have been running virtualization actually for many, many years. It was developed by IBM and others back in the late 60s and actually productized, I think, in about 1972. So this is a concept, obviously, that has been with us for many, many decades, but is really come to the fore in the age of cloud computing. So in terms of plans for deploying software-defined data centers, we found in the survey that about half of organizations have either adopted SDDC or they're planning to do so at some point in the future. And we also found that fewer than 1 in 5 have actually opted against an SDDC model. So today it's not tremendously popular. As you can see here, only 3% have already implemented a software-defined data center, but most of the rest really are planning to do so. And we found that about 34% at this point are really not sure. They're not yet decided. They really haven't thought it through completely in the context of how they're going to implement their private clouds, their hybrid clouds, and so forth. We also found, however, that the move to SDDC is going to be relatively rapid. Among those planning to transition their data centers to SDDC, the vast majority are really planning to do so within the next couple of years. So we're going to see a fairly quick uptake of the whole notion of the software-defined data center over the next 24 months as organizations migrate to that model. So Richie, I'll turn it back to you now.
Stunning statistics. Yeah, those are some stunning statistics, Michael. Those last 2 data points about how many people are going to do it and how quickly they're going to do it are really quite striking. So I want to leave us all with some takeaways. First of all, software-defined is ready for prime time. Like I said before, we see this as now a relatively mature market. We want to say that it has definite advantages over a traditional data center. It's also importantly applicable to not just a traditional, if that's the right word, a public cloud world, but also a private cloud world, or indeed a hybrid cloud world. But please do beware traditional thinking about security. There are some vendors that are offering security features that are not, let's call it, software-defined aware. And also, I think, beware legacy products with a thin veneer that are calling themselves software-defined. We see too much of that in the market still.
Richie, quick question about that. Just a quick question about that. In terms of the traditional thinking about security, how entrenched is that? How entrenched is the thinking that of sort of traditional security models as they apply to SDDC, and how inapplicable are those models?
Well, how long have you got? A lot of it really comes down to virtualization. And it's not just a problem with software-defined, it's a question of virtualization in general, but software-defined makes it, I think, more stark. By taking products that are designed for a non-virtualized world, for a bare metal world, and trying to shoehorn them into a virtualized data center or a software-defined data center, those security products are not working at their best because they don't have the full information available to them of what on earth is going on in the fleet of servers in the data center. And so that's why a security platform that is software-defined aware, count the hyphens in that sentence, is so much better because it has the information available to it. And having that information allows it to make much smarter decisions about whether a particular activity is a threat or not.
Mm-hmm. Okay, excellent.
All right. So let's talk about these business benefits that I touched on earlier. I'm going to pull out 5 that we think are, in general, the most important. But you can all disagree about whether these are the most important 5, but these are our most important 5. Speed and security and operating cost and capital cost and interoperability. And I would just make a note here, there's a common misunderstanding when I talk about agility, that software-defined is only really applicable in an agile world or a DevOps world. I don't see that as true. I think that there are plenty of benefits that traditional IT organizations can also take advantage of. So let's talk about that benefit in a little bit more detail then, speed and agility and productivity. In a software-defined world, IT operations can be more responsive to change. Software-defined inherently makes things more easier, not just to configure, but also critically to reconfigure. It also therefore makes it easier to secure and keep secure, assuming, as I say, your security tools are adequate and software-defined aware. Now that is important for DevOps or lean startup or agile development, or call it what you will, but again, as I say, it's also very applicable to traditional IT. Security, we'll touch on now. Software-defined gives you centralized control and management, and it gives you access to, or the benefit of policies consistently enforced. And as I like to say, control plus policy equals security. You can compare that with a traditional operations of a data center, where you have rules distributed across devices, and you're basically dependent on fragile, frangible physical characteristics. And that means that your security rules will go out of date. I guarantee you it will happen. It's essentially inevitable. Whereas in a software-defined world, it's so much more easy to ensure that your security policies stay current and stay implemented in the correct way as the underlying architecture changes. There's a lot more detail on that in the white paper as well. So there's my second plug for going to download the white paper, please. Number 3, operation costs. OPEX, low downtime. In a way, there's 2 sides of the same coin. Basically, you don't have to go and touch your lights out data center. And SDDC makes it not only easy to reduce planned downtime, but also unplanned downtime, because it helps avoid operational errors. And as well, with operation cost goes capital cost. I'm sure lots of you are familiar with the way that virtualization and cloud helps reduce, or perhaps even eliminate in some cases, the capital cost aspect. But we also see those benefits in terms of networking and storage, not to mention security as well. And overall, software-defined helps reduce, in many ways, helps reduce proprietary lock-in, allowing you to choose the, quotes, best hardware for the job. Your idea of best may vary from other people's idea of best, but for example, the most reliable, the best value, and so on. And finally, benefit number 5, interoperability. realizing the inherent benefit of cloud, be it hybrid cloud, public cloud, private cloud, on-prem, off-prem, all of those we're just bundling up in this word cloud here. Again, it's helping you avoid lock-in, and it reduces this idea that I've talked about a few times now of friction in moving a workload. In the life cycle of a workload, we often find that it's optimal for a workload to move between clouds, for example, from on-prem to off-prem or off-prem to on-prem. And that is difficult, and software-defined makes it easier. So in summary then, the four key elements of software-defined: compute, storage, networking, and security. Software-defined focuses on doing a better job with storage, networking, and security than traditional IT. So let's dig into those a little bit more. Let's talk about software-defined storage first. In many ways, in the relatively recent past, I would say software-defined storage has been a bit of an empty buzzword in the industry. There have been plenty of vendors, again, putting this veneer of software-defined on top of basically trying to sell what they already have. And that's becoming less and less true, thankfully. True software-defined storage moves the intelligence of the storage, quote, up the stack. So it integrates the way the storage works with the management of the virtual machines. Again, more detail about that in the white paper. Networking then. When people talk about software-defined networking, you often hear this standard description. Software-defined networking, it separates the control and the data into two separate planes. And yeah, that's a pretty simplistic description, but what does it mean? And it really needs unpacking. I wish we had another hour to properly unpack it, but there is plenty of detail in the white paper. Suffice to say, it creates this functional split between the controller, the controlling devices, and the forwarding devices, which is functions that are normally bundled up into one traditional box or one set of traditional boxes. The point of that functional split is to increase performance, particularly, notably, latency, increase availability, reduce complexity, reduce this operational error point again, and once again, consistently enforce those security policies. And once again, there's much more detail about that in the white paper. In terms of security then, and I'm going to say security as a proxy for security and compliance, because a lot of what software-defined can give you is enforcing policies that enforce regulatory compliance. Security need not be confined to a physical location. It improves the visibility of data, what the workloads are doing with the data, where the data is going, where the data is. It allows you to not just have a boundary security policy, but actually look at how the workloads are interacting and spot threats, remediate threats, clean up threats. But as I mentioned before, when Michael asked me the question, it's important that those security products are able to monitor and understand the true nature of the environment in which the workloads are running, not just a virtualized facsimile of the environment. Now, how does this thing work? Well, there's way more detail about this in the white paper. But again, there's a phrase that I've already used today, which is moving the intelligence up the stack. And I think that is the crux, really, of software-defined. In the past, you had virtualized workloads, but the storage and the networking were basically just working through shims that were emulating an environment because of the way virtualization worked. And there was no magic to that. And there was no particular thought put to why we were doing it in that way. So software-defined rethinks that and moves intelligence into a different part of the stack, principally into the virtual machine platform. And that allows security to do better things and allows all those other benefits that we talked about. And then talking about specifically how the security works, this functional boundary shift that we talk about, it makes really great sense in terms of security. It allows the security software to do a better job of monitoring and blocking and remediating. And this is really because the virtual machine platform is in this unique position. It can see what workloads are doing. It can see what potential threats are attempting to do. It sees that in context. And not only that, it sees the totality of the behavior across virtual machines. So that's potentially much more powerful, much more robust, especially if you're talking about comparing it with traditional boundary security. Intrusion protection, data loss prevention, and so on. And surprisingly, say it with me, children, much more detail about this in the white paper.
Well, Richie, thank you very much. Going back to the survey that we did for this program, we wanted to find out what was driving the deployment of the software-defined data center concept and really understand why organizations were even considering it, let alone deploying SDDC. And certainly the number one reason that we found was performance improvement. Organizations are looking to improve the performance of their data centers in a way that they really haven't been able to do thus far, and particularly as they add more applications, more capabilities, and so forth. Certainly a close second was improving security. As we move into a virtualized world, as we move into cloud-based applications and so forth, improving security is going to be a paramount concern. But then we also found a number of other drivers, including things like reducing capital expenditures, enabling better control of the application and the software environment, improving business agility is something that Richie has alluded to, reducing operating expenditures, another important consideration. And then also for some organizations, it's really sort of future-proofing their later cloud deployments, implementing the capabilities today that will enable new cloud applications, new cloud services to run. And then finally, a driver for some organizations, fewer than a third, frankly, was really reducing the complexity of their environment. And certainly these drivers are going to change based on the size of the organization, how heavily regulated they are, and really based on a number of factors. But across the population that we surveyed, across the different types of organizations, we found that these were the primary drivers, certainly performance improvement and improving security. So in summary, certainly the SDDC model is maturing, but it's not yet completely there, if you will, for many vendors. A lot of vendors are at various stages in their SDDC journey, and some solutions are more complete than others. Different vendors really have differing views about the software-defined data center, so you have to be absolutely clear on the terminology that those vendors are using when they describe to you what they see as the current state of SDDC and where it's going. You need also to ensure that future purchases really don't lock you into some sort of proprietary vision of SDDC. That's, as Richie alluded to, that's a very easy thing to have happen. You want to certainly avoid that sort of vendor lock-in. And SDDC can't really magically fix any badly planned or applications that are inherently secure or that don't perform poorly today. This is not a magic bullet that's going to solve all of the problems. These applications do have to be secure, they do have to perform well, and SDDC cannot solve all of those problems. And finally, SDDC offers a number of very important benefits, and it really should be a very high priority for any large organization to consider, let alone deploy. Okay, at this point, I would like to turn things over to Wade Holmes of VMware. Wade, the floor is yours.
All right, great. Thank you. So today I'm going to be talking a little bit about, so we talked about this concept of the SDDC and how the SDDC can enable better security and how a number of customers and other organizations are adopting SDDC for security. But also we want to look at making sure that the solutions and products that you choose for SDDC truly is going to enhance your security posture. And as mentioned previously, that it isn't just a product that has a thin veneer of SDDC capabilities, but are actually a legacy, actually have a legacy model, because in actuality that will hamper your ability to have a secure SDDC solution. So basically, we're talking about looking at how we can leverage NSX, which is VMware's networking and security virtualization platform, and McAfee security products to have that agile, secure SDDC. So first, what is the problem, and why is this even necessary? Why do we need security ingrained into the SDDC to enable a better security posture? So organizations today have been seeing a vicious cycle of security failure, and we see this cycle is being compounded as new technology is actually being adopted. There's no lack of spend in the amount of, there's no lack of spend for new security products, new technology, with the goal of having better agility, better performance, better security. But if these products aren't built for SDDC, you can get into a inefficient cycle of potential security failure. So what does a cycle actually look like? An organization will procure new technology to attempt to overcome a capacity burden or enhance performance. There will be isolated effectiveness in the security posture of the organization as these as new threats are able to adapt to this new technology. Part of this reason for this is due to a lack of a truly integrated strategy to prevent technology sprawl. So you don't have, that would cause there to be just point solutions with siloed technologies that have diminished efficiency. And then you have overburdened teams that are left that are constantly in a reactive, tactical posture, that are reacting to threats, reacting to adversaries, instead of strategically being able to address the true underlying security posture of their organization. So when an organization operates in a tactical mode without any practical way to integrate new capabilities in an overall platform approach, we end up with this technology sprawl and limited half-life of efficacy of isolated, siloed security solutions. I like to, we talk about a concept of defense in depth. Obviously, everyone, most security practitioners will agree that defense in depth is an important concept to truly have a secure organization or secure infrastructure. But if your security products, if you have 100 or 200 siloed security products, which actually is very common for many large organizations to have over 100 different security products that aren't able to communicate, it isn't strategically put together, you're going to have these pockets of siloed security that attributes to this vicious cycle of security failure. None of the pieces work together to accelerate the ability to comprehend and defend the organization, and then you end up needing to just throw bodies at an increasingly complex environment. So basically, it's not that we shouldn't be adopting technology, it's that we should be looking at how we onboard new capabilities that are able to programmatically utilize the inherent capabilities for a strategic approach to integration, automation, organization, and orchestration of your security posture and of your data center. So, and I don't really need to talk about some of the threats in this current day and age. I think everyone or majority of viewers here will be familiar with the ransomware attacks that have happened in the last couple weeks. These are older statistics on this slide, but they now seem pretty prophetic. In this states that the number of desktops hit by ransomware in the past years doubled to over 300 cases. In the last week, we just had a incident of the WannaCry ransomware that hit over 200,000 deaths, 200,000 endpoints in over 150 countries. So the threats are getting worse. There are sponsored threats that are targeting organizations, and organizations need to be able to have a strategic defense against these threats as they continue to proliferate. So let's talk about how we have a more cohesive threat defense lifecycle. So this strategy looks at being able to unify capabilities to be able to protect, detect, and correct in real time with centralized management into an adaptive feedback loop in order to avoid, reduce, and mitigate risk while simultaneously optimizing resources. So this threat defense lifecycle allows security to evolve and learns in an iterative cycle and improves over time when these capabilities are ingrained into the actual infrastructure and leverage the actual capabilities of SDDC. So no longer are you looking at it from approach of how do I secure these new technologies, this new deployment model of FDDC. You utilize an approach of how do you use some of the intrinsic capabilities of the FDDC to make the security posture of your organization more secure and inherently secure. So this is where we enter how NSX as VMware's networking and security virtualization platform in combination with partners such as McAfee Security can allow for that intrinsic level of security within your data center. So this occurs basically by utilizing the capability of virtualization, which is a building block of SDDC, and having that privileged position within the software component that makes up a virtualized FDDC called a hypervisor to have a level of visibility and a privilege enforcement point to be able to provide better security. So this also enables a concept called microsegmentation. So basically, microsegmentation, as enabled by NSX, allows for this ubiquitous software layer to become a platform that has some very unique and powerful characteristics. It allows for things such as distributed stateful firewalling, which can reduce the attack surface within a data center. Basically, using this approach, you can have a consistent data plane that scales as your compute infrastructure scales, allowing protection and visibility on a per application or per workload basis. It allows for you now to have topology agnostic segmentation. I mentioned this ubiquitous software layer that now allows for providing application firewall protection regardless of your underlying physical topology. Whether it's layer 2, layer 3, this agnostic of network and hardware, and it provides these logical overlays of within your network infrastructure. Also, I mentioned previously, policy is key, where you want to be able to have a centralized, ubiquitous policy control of these distributed services. And these are all things that are enabled by NSX as a security platform that can then integrate in with our partners, such as McAfee. Being able to then have granular unit level controls implemented by different high-level policy objects, utilizing mechanisms such as grouping mechanisms for object-based policy and down to a granular application level independent of specific network constructs. Another key enabling capability is being able to provide isolation, network-based isolation, utilizing logical switches or network overlay technology. And this will allow you to be able to span the networking capabilities of your data center on demand and independent of the underlying network and physical topology. And then last but certainly not least is being able to have policy-driven, unit-level service insertion, and that's where the products such as NSX as a network virtualization and security platform and the capabilities of McAfee come together to be able to provide this third-party introspection via the capabilities of McAfee security, and on a granular basis, utilizing this foundation of this ubiquitous software layer that NSX provides, and then having the additional advanced capabilities that McAfee provides on a per workload or even per flow basis through technologies such as network introspection and guest introspection provided by NSX. So basically, at the end of the day, this allows for you to optimize your security for your virtual servers, your virtual desktops that define the software-defined data center, and ensure that you have a centralized security strategy that has the capabilities are built into the infrastructure as you scale out your data center.
Okay, excellent. Wade, thank you very much. And I'd like to now turn things over to Peter. Peter, the floor is yours.
Okay, thanks very much. What I'm just going to do for this section here is I'm actually going to build on a few of the things that Wade covered there. There's a few terms that came out, a few ideas, which are, for us, central into how we can actually take security and make it software-defined security. Now, there's the idea of automation, but there's the idea of abstracting away from underlying hardware, network hardware, things like that, hardware-based intrusion prevention, hardware-based firewalling, etc. And the fact that we have this programmatic layer that NSX gives us in the case of VMware is very, very significant in how we can not only build on the security that we have in a virtualized environment, but significantly improve it. What I just want to start with here is a picture that's probably familiar to anyone who's tried to set up a segmented application, three-tier application in the old world of a virtual data center. Now, I always call this out as being a virtual data center. I want to be very, very clear that all we are virtualizing here is the compute. The networking is still physical, the security is going to be physical. And that's really quite significant because a virtual data center is absolutely categorically not a cloud. So what we have is these different silos of technology, compute, network, and security, essentially working independently. Now, I spent far too much time with virtualization, building data centers to pass PCI DSS audits and various things. And one of the big problems we had was how do you actually, if you've got multiple virtual machines sharing hardware, how do you segment them? And how do you do any kind of intrusion prevention? So what we've got here is a very, very traditional, this is pretty much a best practice deployment that says I'm going to take my web, app, and DB tiers, and to segment them, each tier is going to be bound to its own virtual switch. So even without NSX, vSphere provides a level of virtual networking, but it's just the switch. And one of the rules about virtual switches is they can't talk to each other across the hypervisor. The only way they can talk to each other, as we see in this diagram, is by going out onto the physical network and then going back into the hypervisor. So what we've seen people traditionally do in these environments is to say, great, well, I'm going to have my three-tier application. I have a perimeter firewall, and I have perimeter intrusion prevention systems. So what I can do here with a nice little bit of switching or routing, I can actually provide segmentation and inspection for each tier of this app. So if we could go next, please. Okay. So, oops, sorry, that didn't animate at all. Never mind. Let me explain that through for you. So what we have here is an end user. It could be somebody out on the internet who's a customer. It could be somebody internal to your organization going from different parts of the organization. Now, what happens here is that when somebody connects in, absolutely great. They go through the firewall. That does all the inspection. It makes sure that, that it's the right service, it's the right IP address. Goes up through the IPS, looking deeper in the packets, layer 7. goes to the virtual switch, and hits the web server. Now, the problem with this is that as soon as you have that web-to-app communication, what automatically happens is the traffic is tromboned out, goes back out through the physical network card, it comes all the way back in, and it's gone through the firewall again. And then when app talks to DB server, exactly the same thing happens. Now, that may be all well and good on a small environment, but you know what? We're going to make things even more challenging here. We've implemented network protection. What we're also going to do, just to be sure, is we're going to put an antivirus agent, there in red, on all of the workloads. So we have network protection, we have endpoint protection. But is this really a good idea? Next slide, please. A few of the problems. We see this again and again and again, but one of the inherent problems of having the network and the security living in a different domain from virtualization is it's not scalable. If I wanted to scale out that environment, I would literally be shutting down the hypervisor, installing a new physical network card, restarting it, which is about as far away from cloud as you can imagine. It's also pretty inelegant as a network design. I mean, I say for a small environment, yeah, that's probably okay if you've got a small static environment. But really, as soon as you start to load those primitive devices with more and more controls, things start to get messy. So as I said there, the physical network security and the compute exist in separate domains. The big problem, and I know this was mentioned earlier about security configuration drift. One of the problems here is that if you try and scale this up, you're going to be routing more and more traffic through your IPS and the firewall. And what happens then is that the rule bases of those systems just grow and grow and grow. It's very common for somebody to take architecture, and when they want to scale up their organization, what do? They repeat it. And more traffic is going through a perimeter firewall. Now, what happens very quickly to cause the security drift is people add rules to the rule base. Now, I spent far too many years being a checkpoint and a Juniper firewall administrator, and I would say probably every week I was asked, Peter, could you add a new rule to the firewall rule base, please? Great. I have essentially no recollection of ever being asked to remove a rule from the rule base, the law of unintended consequences. So what happens is you end up with this essentially junk rules that as the environment changes, people don't clean up the rules. One of my customers here in Europe, they many years ago, they created an environment quite similar to this. And over the years, they scaled up and scaled up and scaled up, replicating that environment. When they finally came to turn around and say, is this actually fit for purpose? They thought, well, it must be auditable. It's a physical device. What they actually found out was they had a rule base that had grown up over 5, 6, 7 years that consisted of approximately 6,500 rules. They actually failed their own audit. So that's really the networking problem. Remember, we also loaded antivirus onto here as well, anti-malware for each of the VMs. That can be a fun proposition if you have a very heavily consolidated environment like virtual desktop, because all of those workloads are sharing resource. So when each of the antivirus agents says, you know what, I need to run a scan on this system, what happens? They all say, I have a high priority process, give me resource, and you end up with this quite ironic situation where your antivirus actually creates a denial of service condition by drinking up the resource. Now, that's what we call an AV storm, and to be quite honest, the same thing happens when you're doing DAP file updates. So if we just look at these two cases and how SDDC actually helps us, and basing this on vSphere and NSX, a little example here. So our intrusion prevention system is called NSP, the Network Security Platform. And of course, those people who use it, many are familiar with it being a big piece of hardware, flashing lights and cables, etc. But very specific to a VM environment, we can deliver NSP as a virtualized appliance. Now, what this gives us is we're not internally hairpinning traffic to and from a device. We're using the APIs that Wade mentioned earlier that NSX gives us to actually insert this function at the virtual network card of every single workload. Now, the thing is that this actually works to our advantage and VMware's advantage because it's highly, highly complementary. So if you look there, one of the things that NSX gives us is a distributed stateful firewall. It's a kernel module. It's not a virtual machine or anything. It's running right down at the kernel of ESXi. If you wanted to look at that another way, could we have the next slide, please? Thank you. What we'd see as an example is here we've got a web server that needs protecting. So what we're going to do is we're going to use the stateful firewall. We're going to create policy, and that policy contains a rule that says only port 80 and only port 443, so HTTP and HTTPS, are allowed as communications to my web server. So that is the remaining 65,000 plus ports automatically and instantly shut down by NSX. What we do, again, policy and programmatically, is insert that deep packet inspection technology into the two open ports. So not only do you have a fundamental lockdown, it's this zero trust model, etc., you also have the higher orders of traffic inspection exactly where it's needed. And the really clever thing with this is that because we talk to the NSX manager, the NSX manager talks to the virtualization manager, vCenter. Whenever you create a new virtual machine, it's protected. Whenever you destroy a virtual machine, the protection is removed. And most significantly, when you actually move and migrate virtual machines, the protection moves with them. Now, that's with the network side. I'm just going to give you 2 minutes on the actual endpoint side, just to give you an idea of how NSX and SDDC helps us there. So when we start looking at providing antivirus, antivirus has been a problem for people in virtualized environments for a long, long time, AV storms, DAP storms. What we do is we have a technology called Move, which is McAfee Management Optimized for Virtual Environments. And the idea here is that instead of having the full fat antivirus ability or capability on every virtual machine, we offload it to what we call a dedicated offload scan server. And in the case of vSphere, what we're doing is all we actually need to make this work is for the VMware drivers to be installed, which is VM tools. Once that's done, all antivirus functions actually happen across the backplane of the hypervisor, so it's not network-based. We're aware of what NSX is doing. NSX is aware of what we're doing. So you get this virtuous circle of when the workload is provisioned, the security management knows about this and makes sure that the antivirus is provisioned. For those of you working across a broad array of hypervisors, we do, of course, support pretty much all of the main hypervisors with the version that we call multi-platform. The only difference there is that we do actually require a McAfee agent on the systems because not all hypervisors are quite as extensible as the approach that we get with vSphere. Now, that's been a huge amount of architecture. That's been network security and endpoint security in close to 10 minutes at least. I'll say thanks very much. Look forward to any questions and hand back over. Thanks very much.
Excellent. Well, Peter, thank you so much. We would like to get to some questions now. Here is our contact information for all four companies if you do have any further questions. First question that came in, Wade, could you go a little bit more into more detail on the policy level service insertion that you mentioned?
Sure. So basically with NSX, we have a tool called Service Composer that can tie into creating security policy and then applying security policy based on security group constructs. And these policies and groups can be formed by different objects within your vCenter inventory, whether it can utilize traditional static objects such as IPset, MACset, physical machine, or you can actually have higher level dynamic objects such as Windows OS or all of the VMs that are created on a specific logical switch and automatically would be inherently part of a security group, and then they applied the security policy. And the security policy framework is then tied into by our partners such as McAfee to be able to leverage these same constructs to apply the capabilities of both their IPS solution and their endpoint solutions.
Okay, great. Thank you very much. Another question has come in. Peter, I think this would be directed to you. Are there any benefits in the context of licensing costs for security by going to an SDDC model?
Sorry, could you repeat that again, please? Sorry, that was a bit...
Sure. Are there any benefits in the context of licensing costs by going to SDDC?
Yeah, really. I mean, it's if you were to go for a similar architecture where you actually have this zero trust model, etc., the sheer number of firewalls and intrusion prevention points that you would have to insert into a network would honestly make this, it would start to get ridiculously expensive very, very quickly. So if you can actually not just move the technology into the hypervisor, but also have licensing that reflects the fact we're on a shared hypervisor, etc. We have, we can start looking at different ways to license. And also, if you think about how flexible a virtual environment is, potentially when you're running SDDC at least, it actually becomes quite arduous if you do things like per virtual machine licensing to actually try and keep up with the workloads deployed. So especially if you own the architecture, it becomes a lot more of a sensible idea, a lot more of a manageable idea if the licensing is maybe at the CPU at the core rather than being individual virtual machines. Because I mean, a hypervisor, it could have 10 virtual machines on it, it could have 100. It all depends on what the actual capacity requirement is at any given moment in time. That was a very long way of answering yes, by the way.
Okay, very good. Well, that's all the questions that we had come in. Richie, Wade, and Peter, thank you so much for your excellent content, and I would like to thank everyone who participated with us here today. We will be sending you a link to the white paper that was sponsored by VMware and McAfee, as well as a link to this webinar recording if you want to review it or share it with others. And again, thank you all very much. That concludes today's webinar.
Thank you.
Thank you.